Hi guys, welcome to the third chapter of the series Some Shades of Math, and today with one more question of a Math Olympiad, and actually now about the sum of two square roots with an integer number. Okay, so the question is, for which values of positive integer n, the number square root of n plus square root of n plus 5 is an integer? In a previous problem, we worked about unity fractions, when the sum of two unity fractions is an integer. In this case, we have two numbers which seems to be rational, but we need to see this. Okay? So for solving this, we shall prove actually first two facts. So fact number one is, if square root of a plus square root of b, where a and b are integers, if this is a rational number, then square root of a and square root of b must be rational. Okay, so how to prove this? The proof is the following. We can write square root of a minus square root of b equal to a plus b a minus b divided by square root of a plus square root of b. Yeah, because the product of this number with this number is equal to a minus b. Okay, a and b are integers, so a minus b is integer, and our hypothesis is that square root of a plus square root of b is rational, so this number must be rational. Okay, so what happens if square root of a plus square root of b is rational? Implies that square root of a minus square root of b is rational. But we know that the sum of two rational numbers is still a rational number, so square root of a plus square root of b plus square root of a minus square root of b, this must be rational number. But this is equal to 2 square root of a. And this implies that square root of a is an integer, is a rational number. Okay? In the same way, we can prove that square root of b is rational by subtraction here, because we know that the subtraction of two rational numbers is still a rational number. So square root of b is an integer, is a rational number. This is the fact one. The fact number two is, if square root of a is a rational number and a is a positive integer, is a natural number, this implies that a must be a perfect square. Okay, so a is a perfect square. How to prove this? Suppose that square root of a is a rational m over n in irreducible fraction. So the greatest common divisor between m and n is equal to 1. Okay, so I can square this equality, and I will have a is equal to m squared over n squared. Since a is an integer, this implies that n squared divides m squared. But since m and n are coprime, they don't have common factor primes, so n squared and m squared are still coprime. So if n squared divides m squared, this implies that n squared is equal to 1. This because the greatest common divisor between m squared and n squared must be equal to 1 too. Okay, so if n squared is equal to 1, this implies that a is equal to m squared. So a is a perfect square, as we want to prove. Okay, so coming back to our problem, we know that square root of n plus square root of n plus 5 is an integer. So these two guys must be rational. So coming back to the problem, so the solution of the problem, square root of n and square root of n plus 5 must be rational numbers. But this is by the fact number 1. This is fact 1. But by fact 2, this implies that n plus 5 must be perfect squares. Okay? So n must be some r square, and n plus 5 must be some t squared. So I can subtract these two equalities, and I will have, in order to delete this n, so I have 5 equal to t squared minus r squared. Sorry again, r squared. And this I can write as a product of t minus r times t plus r. Okay, but these guys are integers, and 5 is equal to 1 times 5, because 5 is a prime number. So since we have two positive numbers here, and we have this factorization in the left side, the smaller guy must be the smaller guy of this side, and the bigger guy of the right hand side must be equal to the bigger guy in the left hand side. So t minus r must be equal to 1, and t plus r must be equal to 5. And by solving this very easy system, we can sum, and we have 2t equal to 6. This implies that t is equal to 3. Okay, if t is equal to 3, this implies that r is equal to 2. So n is equal to r squared. So this is 4. Okay, and n plus 5 is equal to 9. So the only solution in this case for which values of n, the only case of n is equal to n equal to 4. So square root of 4, which is 2, plus square root of 9, which is 3. So the sum is equal to 5. Okay guys, so I hope you like. If you like the video, you can share with your friends in your social networks. And see you in the next video, and leave your comments to me. Bye bye. Thank you.